Okay, class, today we're going to be looking at costs and cost volume profit analysis. But before we get into the analysis, we need to look at some of these costs. So we're going to look at fixed costs, variable costs, and mixed costs. It's really important that we divide all of our costs between fixed and variable. And then we have some that are mixed that we're going to have to divide up on our own. Alright, a fixed cost, like it says here, remains unchanged in total with regards to volume of activity within the relevant range. Okay? So what we're talking about here, a good example is straight line depreciation. Let's say we're manufacturing our product, and let's say the machinery that we use, we calculate to have depreciation of $1,000 per month. That doesn't change. No matter how many units we produce, our depreciation will be fixed at $1,000 a month. But let me point out here, that's within the relevant range only. Because you can imagine that if we start manufacturing or need to manufacture a whole bunch because demand has increased, then maybe that machine can only handle maybe 5,000 units a month. Let's say demand now is more like 10,000. What's going to happen? Well, we're going to have to purchase another piece of machinery, and then our depreciation would go up. But within the relevant range of 0 units to, let's say, 5,000 units, we can use this piece of machinery to manufacture this product. So, $1,000 would be fixed between that relevant range of 0 units and 5,000 units. Variable costs change in proportion to changes in volume. Okay? Materials and labor are good examples, direct materials and direct labor are good examples of variable costs. Okay? Let's use materials for our example. Let's say we were manufacturing a table, and let's say that it requires $50 worth of materials. Okay? If we manufacture one table, what's the total dollar amount of materials we'll need for that one table? Well, I said it was $50, so that's what it would be. It would be $50. If we manufacture 2 tables, then how much materials will we need? We'll need $100 worth of materials because there's 2, and each one will need $50. If we manufacture 3, 50, 50, 50, $150 worth of materials. Okay? So it varies depending on the number of tables we manufacture. Okay? So change in proportion to changes in volume. Mixed costs include both variable and fixed components. Okay? A good example of this is your utility bill. Even if you did not use any electricity during the month, the utility company is still going to send you a bill because there's a fixed component to the bill. It's a set charge. Okay? As you start to use electricity, what happens to your bill? It's going to go up because it also has a variable portion to it. So it's got a fixed and variable. Now, I said earlier that we're going to be looking at cost volume profit, CVP, cost volume profit analysis. And for this, we need to divide all costs between fixed and variable. So these mixed costs need to be divided up. We need to figure out what the fixed portion is and what the variable portion is. Okay? Now, there are really three ways of doing that. And where's my pen? Here it is. We've got the scatter graph or scatter plot method. We've got the high-low method. And then we've got what we call the least squares. Sorry, my handwriting's not very good down there. It's the scatter graph or scatter plot method, the high-low method, or the least squares, or sometimes we call this the regression analysis method. Okay? Now, I'm going to skip down to the high-low method first, and then I'll come back to the scatter graph. The high-low method is you're going to look at your costs for whatever this mixed cost, because remember, once again, we're looking at the mixed costs, and what we're trying to do is break out the fixed and the variable portion in our mixed costs. So what you do is you look at the activity over, let's say, the last year. So the last year you look at all your cost for whatever this mixed cost is, and then you compare it to its activity. So what you're going to do is you're going to look at the change in total cost, and you're going to divide that by the change in units or activity. Okay? So I'm just going to use my own example. I'm going to make something up. Let's say, and you're going to look at the high and the low. So let's say in this 12-month period, the high for this bill was $30,000. Okay? And at $30,000, at 30,000, let's say that we had 5,000 units of activity, okay? We're going to then subtract out the low. So we're going to take the high and subtract out the low. Let's say in the 12-month period, the low was $18,000. This is thousands. $18,000. And let's say that our units were only 2,000 units that month, okay? So we had $30,000 worth of expense in one month, and we produced 5,000 units. In another month, our lowest month, we had $18,000 of cost, and we only produced 2,000 units. So now we just solve for this. We get 12,000 divided by 3,000, which gets us $4. And this is our variable cost. That's our variable cost, okay? Now what we do is we need to figure out the fixed portion of this. Well, we know our total cost is 30,000. So total cost equals fixed cost plus variable cost. Our total cost, now you can plug it into either one. You can either do the high or the low. I'm just going to use the high. 30,000 equals our fixed cost is what we're solving for. Our variable cost, we already know, we had 5,000 units times, we just solved the cost, $4. Okay? So then when we solve this, fixed cost plus, that's 20,000. So then when we solve this, our fixed cost is $10,000. Okay? So I just took the 5,000 units times the variable of $4 per unit. That got me 20,000. Our total cost was 30,000. So now I just subtract 20,000 from both sides. We get 10,000. So our fixed cost is 10,000. Our variable cost is $4 per unit. Now, I could have done the same thing. I could have used 18,000 for total cost equals fixed cost plus, then this would have been 2,000 times 4. That would have got me 8,000. 8,000 subtracting from 18,000 would have got me 10,000. So it gets me the same answer, okay? So this is how you do the high-low method. You take the high activity and you subtract the low activity, and then you solve to get, and that gets you your variable, and then you solve to get your fixed portion. Now the next one I'm going to look at really quickly is the scatter graph. Now with a scatter graph, what you do, and I'm going to try and do this really quickly, you plot all of your activity for that time period. So this is cost, and then these are units over here. 10, 20, 30, these are thousands. So 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. Okay? So, okay, so let's say this is what took place during the year. So now what I do is I just put a line, the best fit line that I can. So these dots were the activities that took place there. I'm going to add a few more in there. This is the activity that took place during the year. Okay? So now we just put a line that's the best fit, our best line that we think would go through the majority of these or come close to most of these lines. Okay? So at 30,000 it looks like we hit 7,500. And right at 5,000 we had zero activity. Okay? So you just want to put a dot on the line where anywhere on this line, and I just picked 30,000 just because it's going to be easiest there. But you could do anywhere here to solve for this. So now the low is 0. So I'm going to use the same thing. I'm going to do change in cost, change in units. So it's very similar to the high-low method now. I'm going to pick my low. My low is 0 because it's right at 5,000. So that's actually our fixed cost. Our fixed cost is 0. And then our variable portion is what we're going to calculate here. So the change in total cost, we went from 7,500 minus 5,000. And at 7,500 we had 30,000 units. And at 5,000 we had 0. So now when we solve for this, we're going to get 0.08333 on forever. Okay? So this is our variable. And our fixed was right there, the 5,000. Okay, so this is how you do the scatter graph. This is the scatter graph or scatter plot approach. Now the third one I talked about was the least squares or regression analysis. And what happens is you plug these numbers into a software package or even into your calculator, or Excel can even do this. And you plug these numbers in, and then the software package or your calculator or Excel will calculate the best fit line and will tell you what the variable and the fixed cost is based off of statistical analysis. So it statistically analyzes this information and gets you the exact best fit line and gives you your fixed and variable. Okay, so this one obviously is going to be your most accurate one. Okay, but these two here can be used also. All right, I hope that helps you, class. We'll go into cost, volume, profit analysis in our next video. But once again, you need to make sure that you understand your fixed costs and variable costs, and then your mixed costs need to be divided between fixed and variable, because it's very important that we know what our fixed, and total variable costs are for our next step. All right, thank you.